All right, everyone. Let's continue our discussion to hypothesis testing. And you can say, no, sorry, you can see that hypothesis testing and confidence interval, they have the same title. It's inference based on a single sample. So we are still dealing with a single sample, and we are using the only sample we have to make some inference about the population. So hypothesis testing, the name kind of justifies the meaning of all these calculations. Is that we will come up with a hypothesis about the population and then we test it. So, like I said before, anything related to the population mean, the population proportion, we don't know about it. We we don't know the exact number. However, we can guess, and we can come up with a hypothesis saying that we guess this is equal to the population mean. And then we are going to test our hypothesis. Now, how do we test? First of all, we need to form two kinds of hypotheses. The first one is null hypothesis. The second one is alternative hypothesis. And always remember that the null hypothesis always has the equal sign in it. That's the only form of null hypothesis. And alternative hypothesis could have not equal, bigger, or smaller. And the relationship between these two hypotheses is that for most of the question, the alternative hypothesis is the hypothesis that you want to study, right? For example, if a question says we want to find out, the is the mean of a if is the mean of the height of a group of people is bigger than 1.7 meter, then your alternative hypothesis should state the question you want to study is that the mean is bigger than 1.7. And no matter what kind of question you are studying, the null hypothesis always stays with the equal sign. And the testing process is actually to decide whether the null hypothesis will be accepted or rejected. If you accept, if you cannot reject the null hypothesis, then you cannot accept the alternative hypothesis. However, if you reject the null hypothesis, then you can accept the alternative hypothesis. Seems like a either or question, right? And you will make two types of error. The first one is type 1 error. Is you reject the null hypothesis. However, it is true, and the probability is denoted by alpha. The second type of error is type 2 error, is that you can't reject null hypothesis. However, it is false. The probability is denoted as beta. Pay attention to the alpha here. Right, we won't discuss beta in detail, but we will discuss alpha. Pay attention to the alpha. Recall that in the confidence interval chapter, we say that we want to construct a confidence interval of y minus alpha. Right? Sometimes the confidence interval is 90%, then the alpha is 10%. And here in the hypothesis testing, it says that we reject our null hypothesis. However, it is true. And the probability that will happen is what? Is the alpha, is the 10%. Say we are 90 for example, say we are 90% sure that we can reject non-hypothesis. However, there's 10% probability that the non-hypothesis is true. I will explain why this is equal to alpha. The probability is equal to alpha. It's not a coincidence. So this is how we do test. This different alpha has different z-score, and if you go over the z-score, you should reject it. And also, similar to the confidence interval chapter, there is 3 types of hypothesis testing that we will discuss. The first type is, of course, hypothesis test for the sample for the population mean of a large sample, test of a sample mean of a small sample but a normal distribution. And then the one last is that the hypothesis test for population proportion of a large sample. Right. So for these 2 chapters, there are only these 3 types of samples that we will consider, and only 2 types of sample statistic. One is sample mean, and the other is sample proportion will be considered. Okay, so let's take a look at the hypothesis test for population mean of a large sample. The first one is a two-tailed test. The reason why we want to do two-tailed test is we want to find out whether the population mean is equal to a certain number or not. Right, and this is how we do test. Here is the sample mean we get from our single sample. This is standard deviation, everything is normal, and then this is how we reject it. A two-tailed test and one-tailed test is easy to understand why we use two-tailed or one-tailed. And if you take a look at this formula, you may feel, well, it's just calculating z-score, reject. Don't you think that this is quite similar to confidence interval, to construct a confidence interval? Right, for two-tailed test, right? Let's make an example. Let's just say we want to do a hypothesis test, and the confidence level is 90%, meaning the alpha is 10%. And when do we reject the non-hypothesis? The way we reject is the z-score, the absolute value of z-score is bigger than the z-score correspond to the confidence level. And if we write this in full detail, how to calculate z-score is here. Right, and then we get rid of the absolute value. So it should be, oh wait, I made a small mistake here. So this is why we reject it. Remember the confidence interval, oh, I made a stupid mistake here. The confidence interval is confidence. We cannot reject those things in confidence interval. So we should consider the situation when we shouldn't reject the non-hypothesis. So it should be smaller and smaller. See? Okay, right now. Then we get rid of the absolute value. Let's look like this. right? Then we rearrange a little bit. It will looks like this. Right? So this is very obvious. We also get the same formula in the confidence interval section. So if we once again come back to the sampling distribution of sample mean. At this time, you can see this is mu 0. It has a small 0 subscript here. It means that we are considering a hypothetical situation. We guess the mu is equal to this. So the distribution should has a mean equal to this. And this is the interval again. Here the probability is 90%. Right? If our sample mean lies within this range, then we cannot reject null hypothesis. Then we are 90% sure that the population mean could be the one we guessed. However, if the sample mean we get lies outside the 90% range, then we would reject the null hypothesis, and we say we are 90% sure that the population mean shouldn't be that value. Right? That's how we do testing. And come back to the type 1 error. The type 1 error says we reject something. We reject the null hypothesis, but the null hypothesis is true. So in this graph, if our sample mean, the only sample mean we get, lies outside the 90% range somewhere here, we would reject our null hypothesis, right? But there is probability that the null hypothesis is true, the population mean is here. And you can tell it by the graph. The sample mean could lie here and here. Then we have a type 1 error, right? So what is the probability of the type 1 error? It's the probability that our sample mean lies in this region and this region. How much is that? It's 10% because this is 90%. Then here is 10%. So that's why the type 1 error, the probability of type 1 error is equal to alpha. And here is 1 minus alpha. So you can see, if you combine this with the formulas we got from the confidence interval section, the hypothesis test, especially for the two-tailed hypothesis test, is just the reverse of our confidence interval. Right? The confidence interval is we construct the interval here. The hypothesis test is the reverse. And one more thing is that the hypothesis test will assign a hypothetic value to the population mean, so that we will know all the detail about this distribution, the distribution here. So that's how we do hypothesis testing, right? Right now it's easy to understand. It's comprehensible. And we can use the similar method to justify the one-tail test, right? If we take a look at this, the alternative hypothesis is the population mean is bigger than a certain number. And we use the same method. Z is bigger than Z alpha, so Z is bigger than Z alpha, means that X is bigger than mu plus Z alpha. Right, so if we draw the distribution, so the X lies in this range, and this is the situation we will reject, right? X, the sample mean lies in here, we reject. However, if the sample mean lies within this range, within here, we won't reject. So back to the alpha, if we do a one-tail test, we will employ the same alpha, the same confidence level. So it means that, oh no, too much. No, just this off. I'm sorry. I'm so sorry. Here, wait. It means the area of here is 90%, and the area of here is 10%. And this is the alpha. This is the probability that type 1 error will happen. And if you go back to the table here, you can see we are using the same alpha for one tail and two tail. The z-score of one tail is smaller than the z-score for two tail, and it's easy to justify in the table here, right? Because if you take a look at this graph, you need to make the area of this 90%, but you only have one tail left here. But in the two-tail test, you have two tail. So the z-score can be larger than in the one tail, because you are assigning all the area, all the 10% to one side. But here you assign 5% here and 5% here. This is 5%. And if you want to get 10% in one tail, you need to move your z-score back a little bit so that you can have 10%. Therefore, if you think hypothesis testing in this way, it's quite easy to understand, right? You're just constructing a confidence interval, and if your hypothetic value for population mean lies outside your confidence interval, then that value should be rejected, should be discarded, right? Because it's outside your confidence interval. You are not confident about that value. But if your hypothetic value lies within your confidence interval, then you should accept that value because you are confident about it. And we have already discussed why the for example the sample mean is lies in here, it will be within the confidence interval. We have explained that in the previous video. So that's it. That's about hypothesis testing. And yeah, two-tailed test is just construct a confidence interval for construct a two-side confidence interval. And one-tailed test is you just construct a one side confidence interval with only one side, no matter it's in the left or in the right. All right. And another thing you need to consider is that for one-tailed testing, for example, for this one, if you rejected it, what does it mean? You reject it means that your hypothetic value is too big. It should be smaller. You reject the non-hypothesis, but now you accept the alternative hypothesis. So it means that the population mean should be smaller than your hypothetic value. And the reverse is true for this test. It means if you reject this, it means that the population mean should be bigger than your hypothetical. Okay, that's about hypothesis test for population mean of a large sample. Then the second type is hypothesis test for population mean of a small but normal sample. We already, oh, sorry, touched the top of the screen. Yeah, it's here. We already explained why it should be small and normal, and when the sigma is known, you just use the sigma. When sigma is unknown, this is the same for as the confidence interval. You just use t stats with a degree of freedom equal to n minus 1, and use the standard deviation of the sample, and just follow the formulas here. This is the same of constructing a confidence interval, but using the t-stats. And that's it. And also hypothesis test for population proportion. Always remember to check whether it's a large sample or not. And the formula is here, how you reject it. One thing you need to notice about this formula is that here, if you remember when we are talking about confidence intervals, I said if you don't know the population proportion, you can substitute it with the sample proportion, right? I said in the confidence interval section. But here you cannot substitute it. You cannot substitute P0 with P high. But why you cannot substitute? Because here you already know the population proportion, because you set it equal to a hypothetic value. You already know. Then you have to use this value. You cannot substitute this formula with the p hat here. This is wrong. Just pay attention to this. This is only differences between the hypothetic test and the confidence interval. Because in the confidence interval section, we don't know the population proportion. But here you do know it because you set it equal to a hypothetic value. Okay, so that's it. That's the part 1 I want to talk about hypothesis tests. So I still want to make another video about hypothetic test, and we will just wrap it up and talk about what we didn't talk about. But you can see here, you get a general idea of hypothesis test, hypothesis test and how to calculate all this, how to do the test. And that's enough for you to do questions. Okay, that's it. Uh, See you in the next video.